Good afternoon, everyone. This is Bob Celeste from the Center for Supply Chain Studies, and welcome to our Blockchain Your Supply Chain presentation. I will, at the end of the presentation, I'll attempt to open up the line so we can have, if you have any questions or discussion about the presentation and what you've seen. I did try this in our previous presentation. Sometimes there might be someone that's on the line that maybe is having a conversation in their office or something like that. If that occurs, I won't be able to open them up. But I will look at the comments area and I will show you our contact information if you'd like to contact us, and we could have a private conversation. So before we get going, I just want to remind everyone, of course, this doesn't apply to you while you're on mute, but everything that we do at the Center for Supply Chain Studies, we are under antitrust caution in that we don't talk about things to do with pricing, deal making, refusals to deals, sales terms, things of that nature. In our open conversation at the end of the presentation, if you feel like we're getting into those areas, please say so. It'll keep us all out of trouble, and we'll table the conversation until we speak to counsel. The center, for those of you who are unfamiliar with the center, we are a neutral nonprofit corporation. And we work with supply chains to explore complex topics, such as you see here with the Drug Supply Chain Security Act, the supply chain itself and how product is moved through the supply chain, and blockchain technology. So we provide studies for exploring complex topics, and we also provide education on those topics once we complete a study. Everything that comes out of a study, everything that we produce within the study that's publishable, we do publish openly for everyone to see and make use of. And I'll talk you through how we go about studies and a few other areas. So I do want to talk about, again, the studies and how we go about them and how you may be able to participate, and also if there are studies that you may have in mind that may be valuable. I will talk about blockchain technology and what is interesting about it, specifically to the area of the Drug Supply Chain Security Act and the pharmaceutical industry. And a lot of this applies to many industries that are looking to secure information and track product through the supply chain. I'll then talk about our current study that we're starting to wrap up now and starting to develop a white paper around, where we looked at blockchain technology and how it may help the industry comply with the Drug Supply Chain Security Act. And I'll go through why that is and some of the learnings that we had from that study. I'll then talk about a new study that we're going to be undertaking starting up in a few weeks, which builds on the first study where we actually developed proof of concept pilots around the work that we've accomplished. And then I'll talk about another study for cold chain where it's a non-regulatory study, but it is an interesting study where we will build again upon the work we've done in the current study in order to address and share information from sensor technologies, whether that be temperature sensing, humidity, vibration, or what have you. And then some next steps that you'll see take place as we move through this month. So studies at the center, we've had a number of studies that we have either accomplished or are planning on. Last year we did a study on the Drug Supply Chain Security Act and master data management. The issue there is that there is a statement within the Drug Supply Chain Security Act that the information provided from one trading partner to another be provided in a single document. And so this study was taken under to explore the use of normal, proper master data management techniques that the industry already uses. So ways of sharing product information, supplier information, and customer information, location information about the suppliers and the customers, and how that could be applied to the Drug Supply Chain Security Act and maintain secure data throughout the process. That study is completed and the white paper for that is available on our website. We are starting to complete our study on the Drug Supply Chain Security Act and blockchain technology. And in fact, in this study, we, as you'll see, we looked at a number of different technologies, both blockchain and traditional database technologies, to be able to house and provide information in a secure manner to the supply chain that's needed under the Drug Supply Chain Security Act. Our next study that will follow upon that will take the learnings from this study and create a number of proof of concept pilots where we'll actually use blockchain database technologies to be able to transact the DSCSA data. And as I said before, we'll also be kicking off a study to look at, now that we've been able to share information through the supply chain, and we've demonstrated that in our first study, and we will verify that in our second, how would we actually use this beyond regulatory compliance? And so the first thing that came to us was the application of cold chain data, so temperature sensing data, temperature indicators, that type of information, and how we can piggyback upon the previous study in order to provide that data also in a secure environment. So within the center, anyone can come up with an idea to start a study on, and we work with folks that have certain ideas, and certainly the studies that I've just talked about did come from different participants within the supply chain as ideas of things that may be interest to the supply chain, and indeed were. How we go about this is that we will work with you to develop the concept of a study that may be interesting to you. We actually develop a charter for the group that speaks to how the group will go forward, under what time frame, how we handle intellectual property, and how we handle other things that occur within the scope of a study. That charter is then vetted with the community that will participate in the study, and that's through our pre-launch calls, where we're starting to work on firming up the charter for the group, and then we move in earnest into the study. At the end of each study, we'll produce a number of things, artifacts that will be published openly. One of those being typically a white paper on what the study was, what the value was, what we went through, and what we learned. We'll also produce an educational module that will talk about those same things in less of a white paper view, but more of a way of educating. And then we may also produce a series of reference models or simulations that I'll talk about in a moment that will also be available on our website. Again, I talk about the study charter, and we go through that process through pre-launch calls to starting the study to firm up the charter. So for each of these studies, we do have of the new studies, we have draft charters that we can make available to you. But as we start to talk with the industry on those pre-launch calls, we'll start to firm up what it is that our goals are, in particular about the study, and how we'll go about those. So why is blockchain so interesting to the pharmaceutical supply chain and many other supply chains? And so if we think about it from the drug, and now I'm talking about the current study and why blockchain was interesting, and again, this can apply to many other areas and industries. If we look at the Drug Supply Chain Security Act, first, if we just look at the supply chain itself, it's a very complex supply chain with many different processes and many different scenarios for exchanging product and exchanging data. And these are just very, very round numbers, so don't quote me on any of these, but approximately about 3,500 manufacturers provide product within the US. There's about 2,500 wholesalers. There are 3 wholesalers that manage up to 87% of the product within the supply chain, about 7,500 hospitals, and 64,000 pharmacies. So a lot of different kinds of players within the supply chain, and these are just a few. There's also contract manufacturers, 3PLs, returns logistics providers, and a number of other types of companies in the supply chain that interact on a daily basis with each other. In the Drug Supply Chain Security Act, especially when we're talking about the requirements that go into effect in the year 2023, which sounds like a long time from now, but it really is only 5 years from now. Is that? I think I have my math right. But there is a requirement to be able to retrieve the previous transaction information through the supply chain leading back to the manufacturer. There's different interpretations of actually who does that and how that's done. But essentially, if you're looking at the supply chain and look at the numbers of players that are in the supply chain, being able to go back through the supply chain, again, with a environment or an industry that goes through everything that normal industries, any other industry does, mergers, acquisitions, companies going out of business, companies coming into business, a very fluid environment. And being able to trace back means that we need to be able to be connected to each other. And in fact, the Drug Supply Chain Security Act actually does speak about an interoperable system. Also, as I'll talk about some of our goals within the study, one of the areas is if you're going to share data within the system, an interoperable system, we need to have a certain level of data confidentiality. So we don't want to share confidential data with entities that should not be seeing that data. And also, we want to make sure that we're sharing information with entities that have owned the product or have the product with them at that time. So we don't want anybody coming in and fishing for data or looking for information that they could use for other nefarious activities. The data we're talking about here underneath the Drug Supply Chain Security Act needs to be immutable. In other words, it can't be changed by anyone in the supply chain, and it needs to be accessible for up to 6 years. It could be actually longer if there is an inspection. So we're talking about a tremendous amount of data. We're talking about product that is serialized at the lowest saleable level, and information about that product as it travels through the supply chain, and that information be accessible for over 6 years. Tremendous amount of data and a great need for access to that information. So if we look at blockchain, and roughly, and this I'll give you my 3-second pitch on what blockchain is. It's a lot more than what I'm about to say, but just so we could get a sense of it. If you think about transactions taking place from one trading partner to another, the blockchain just gathers transactions. They're not transactions that not necessarily need to be connected to each other. It's just a volume of transactions. In this case, in this one block, we've put 5 different transactions, could have been from different trading partners, and they're put into a block or associated with a block of transactions. When we move to the second block, the first thing that happens is an algorithm takes place that calculates and creates data, a small amount of data, based on the content of the first block. And so that calculation can be recalculated and come up with the same number every single time unless something changes in that first block in any of those transactions. So that hash is included in the second block. The third block then would have a hash of the second block, which would be including the hash of block number 1. And so you start to see this pattern exist, and the value, one of the primary values of blockchain is that it is very difficult to go and change any of those transactions once they're on the block, because you would have to change the hash of the next block and all of those going forward. So if you think about what you see on the left with the number of transactions that take place in this supply chain and trying to alter any of that data, it becomes very untenable. So essentially, we do have a situation where we can have immutable data that cannot be changed. So some of the value around that is that we've got a ledger, if you will, of secure transactions. We can't change any of the data in any of these transactions. There are developing open standards for how you work within blockchains, and that's very helpful for the industry as we move forward. And also the standards take into consideration the experience of the industry. In other words, performance measures, things like that that are needed by the industry. I'll talk about ease of participation in a second, and I'll actually show you an example of that. But essentially, a blockchain is easy to link into. It creates the single source of truth of information that's moving through the supply chain. If we use it for these purposes, everybody sees the same thing. For information that's stored on the blockchain, for information that could be stored off blockchain, and there's techniques around hashing to be able to protect that data also. You eliminate the need of a trusted custodian, so there's no central authority in a blockchain. That data is shared amongst a number of nodes and is available. It also, through what we call smart contracts or programs, provides a common set of rules that can be applied to that data set. And indeed, as we went through our discussion within this study, we did start to create a set of rules that made sense and provided data confidentiality and allowed for trading partners that should be seeing certain data to see that data. So as far as ease, I mentioned ease of connectivity. Let's just look at the most popular blockchain that folks talk about, and that is Bitcoin. And so how do you get connected to the Bitcoin blockchain? Well, one way is that you could simply go on your phone, download an application from the App Store, enter your information in that application, and you're now connected to the Bitcoin blockchain. So very simple. And so the feeling here was that if it's that easy to be able to connect trading partners, and we're talking about a lot of trading partners that come and go, and we've got trading partners that are not adjacent, meaning they don't naturally trade with each other, but they are part of the trading chain, if you will, that will need to be able to share data in the future. So one of the priorities priorities of what we have worked with in the study is being able for companies to be able to connect and start to exchange data with adjacent trading partners and non-adjacent trading partners. And so the same type of thing is desired in the pharmaceutical supply chain, of being able to interact with the blockchain, exchange the necessary data between trading partners, and maybe go above and beyond, and you'll see a little bit of that as we move forward, and exchange certain data with certain trading partners and not others. So I want to talk about their current study, what we did, some of the things that we learned, because this can also be applied to many other situations, scenarios, and industries. And indeed, we'll be using this information as we move forward in our proof of concept pilots and also our application of cold chain data to the same data set. When we started the study, we had a number of discussions where we had to decide what do we wanted to focus on. The supply chain is very complex, the law is complex, and the technology is somewhat complex. And so there's a lot that could be talked about, but we focused on these 6 different areas. And in truth, we focused on the first 5. The 6th one, funding the architecture, may be a future study based on some of the proof of concept pilots. So the first thing is, and we talked about interconnectivity and what we see in the Bitcoin example of being able to connect very quickly to the blockchain. And indeed, in the year 2023, the Drug Supply Chain Security Act calls for an interoperable system. And so that requires that we be able to establish electronic connection between adjacent trading partners and non-adjacent trading partners. We also need to be able to establish trust between these trading partners if they're going to exchange data between each other. We need to know, is this entity that I'm about to exchange data, are they a legitimate participant in the supply chain? That may require, and sometimes looking at licensing and verifying licensing to make sure that they are a legitimate party in the supply chain. It also may be establishing trust that this party has actually owned or has in their possession the item that we're having a discussion about exchanging data. So there's some trust things that need to be worked out prior to exchanging data. The third one here is kind of interesting, and it was a little bit surprising as we went through our discussions in the study. Being able to share the required data that is outlined in the Drug Supply Chain Security Act without inadvertently exposing other proprietary information. And so what do I mean by that? First of all, I'll give you an example of a bottle of medication. And if I'm asking questions about that bottle, I should only get information back about the bottle itself. Even though that bottle may have been packed in a case from the manufacturer, it may have been packed into a pallet, it may have been unpacked, it may have been put into a tote by a wholesaler and delivered to a pharmacy. I only get to see information about that bottle that I have in my possession or my ownership. I don't get to see about all the other bottles that were in all those other cases and totes and things like that. So we need to be able to remove that data when we're answering the question from the party that has the single bottle. Also, there is some other information that could be interesting if you were to look at it over time. And what I mean by that is if I'm seeing information about items moving through the supply chain, I may be able to understand your inventory position, for example, or I may be able to get some information on when your trucks leave your facility, things like that. So we've had a number of discussions on how to obfuscate information unless that trading partner should see that information. Number 4 is sort of an entry-level thing, but we are also looking to not overcomplicate what's taking place in the supply chain or what's taking place as far as complying to the DSCSA law. And indeed, we're looking to reduce the potential activity required of some trading partners. And so as we work through the process and the exchange of information through the supply chain, we're always mindful to try to reduce the steps that supply chain partners may have to do in order to either provide information or retrieve information. And lastly, we were also mindful to make sure the design of what we're talking about allowed for expansion beyond the Drug Supply Chain Security Act compliance, so for other purposes. And you see that hopefully you have an idea that we were successful in that because we're going to be going into a cold chain study where we're going to be expanding upon what we've developed in this current study. But I'll go over a little bit more about that in a moment. Now, as we start to look at the situation, we start to look at blockchain technology, we started to look at the supply chain, we started to look at data confidentiality and governance rules, and also the services that are provided within the supply chain for these purposes. We started to develop a number of, if you will, submodels to our overall model. We refer to these as reference models because we walk through each of the processes with those companies that actually perform those processes, so that we know we have a good reference for whether that approximately or fairly represents what takes place in the supply chain or up in the technology areas. And so I'll go through each of these submodels, but it's interesting to see the areas that we've covered within this study, kind of the breadth. We've done data governance, of course, the technology, blockchain or database. We've covered services that interact with the blockchain or databases on behalf of the supply chain. And we've also covered a lot of the supply chain processes and when and where information needs to be provided. So one of the things we did with the reference models, so this is just an overall framework that we started with, and it fit very well as we started to move through our analysis of the supply chain, the technology, and the needs of the supply chain, is that we started to develop ways in which DSCSA data could be provided through services up into a blockchain or database area and retrieved from those areas. Along the way, we've also defined a number of terms for the use of the study. These terms are defined elsewhere, either in DSCSA law or in general use, but we define them here also so that for the purposes of the study, we could move forward. We developed governance rules as far as data access rules, confidentiality rules, those type of things. We define the process and data flows that take place in the supply chain and could take place in interacting with the blockchain. We defined the data attributes, and you'll see some of that in a moment, and also the kind of information that that the supply chain would need to query on or gather at some point. Once we had those kind of discussions, we started to build out, and we use simulation software in order to manage some of the complexity both in the supply chain and in the data movement within the blockchain. So we started to build using simulation software, simulations that depicted the supply chain and the behavior of the different supply chain trading partners. So the manufacturers, the wholesalers, the hospitals, the retail dispensers, the 3PLs, the contract manufacturers, the return logistics companies, things like that, how they operate at a certain level, and how they generate information and how they consume information from a DSCSA standpoint. We also determined and provided the flow of information up into the data persistence or blockchain area, and up into it and down from it. Each of these models, now when we run them, they actually produce data. And this may be a little bit of an eye chart, but we can show you more in the future on the information that's provided from each of these models. So they actually generate information that each of the trading partners would have under the rules of that simulation and under the scenario that's being run. It allowed us to experiment with sharing information between trading partners, the timing that each trading partner needed to have information based on their supply chain processes, and also start to look at, as I spoke before, data confidentiality. How do we do that? Do we encrypt things? Do we hash things? So we were able to experiment with different ways of securing information and started to narrow down which was the more workable way of doing it. So let's look at some of the reference models we built. And as I stated in the beginning, these studies are exploratory in nature. What I mean by that is we try not to drive to consensus too quickly, because sometimes that takes a little bit of the creativity out of the group. And so you'll see that there are a number of models here that they may never see the light of day, but they were interesting and they provided a good set of learnings from the group to understand different aspects of either the supply chain or blockchain technology. So again, our reference models are based on 4 submodels, and I'll go through this in a second. So if we look at the overall reference model and what we have here is, so for the governance body, and the team actually exercised data governance. We made up rules. We tested those rules. And so the thought here is that the industry would need to come together in order to define the rules for data sharing throughout the industry. Those rules would need to be encoded in an application, or if we're talking about blockchain, a smart contract or series of smart contracts that would enforce the rules set by the industry. So what do I mean by rules? So here's 2 examples of rules. A very simple one, so a properly formatted national drug code or a global trade item number, GTIN, if you're talking about GS1 standards. So we could set within those smart contracts or programs that if the NDC or the GTIN or any other piece of data is malformed, it will be rejected. So we don't want garbage data in the blockchain or in the data persistence area. We want quality data up there. That's a pretty simple rule, and I think everybody agrees that those kind of rules are pretty effective and helpful. There are other rules that we needed to run the simulations in order to understand the constraints around those rules. So you see here another rule that says a shipping event cannot be added unless there's a commissioning event. So in GS1 EPCIS standard language, typically an item is commissioned, it's given its identity, in this case a NDC or a GTIN, global trade item number, and a serial number. And now the item is identified and can be now start to be tracked throughout the supply chain. And so that is considered a commissioning event. And so it makes sense that I shouldn't be able to ship something that's never been commissioned. The issue occurs within the reality of the supply chain. Now, there are times where trading partners, manufacturers, wholesalers are located very close to each other, maybe even across the street. And we may have trading partners that only provide the data once a night. Maybe they do a batch process at night. And so it could occur that a wholesaler has possession of an item that a manufacturer has not yet provided the commissioning event for. So that would, if we actually strictly enforce this rule, that would limit the ability of the wholesaler to actually move the item through their internal environment. So we did experiment with a number of rules and we found some conflicting and we made some adjustments. So this actually helps, the simulations actually help identify these things before we go into physical pilots or implementations. We also, speaking back to the wanting to be able to make sure that this architecture could be used for more than just regulatory compliance, we did also categorize our rules. So there are certain rules that we've defined that we can find a reference to in the DSCSA law. So that's a DSCSA rule. There are other rules that are just general business practices of this particular supply chain and need to be followed. And thirdly, there are rules that occur between two trading partners that have an explicit agreement. So we wanted to make sure that we could express all of that within this model and within the blockchain, if you will, without them interfering with each other. So those are the three sets, and it allowed us freedom of conversation in those other areas that are beyond DSCSA compliance. The data persistence area, as I've been speaking, we have some models that specify a blockchain technology and others that specify a traditional database design, such as we've been talking about in GS1 for at least a decade, discovery services, ONS, checking services, those type of things. The supply chain submodel, we sometimes work with very simple supply chains. You see here a manufacturer, a wholesaler, a hospital. At other times, once the whole model is starting to work, we start to amp up the processes and the complexity of the model and add more internal processes into those entities, or we'll add more trading partners or supply chain partners, such as you see here, beyond just manufacturer, wholesaler, and dispenser. Now we start to differentiate between hospital and retail dispensers. You see a 3PL here, a contract manufacturer, warehousing, and some other nuances. So that part of the reference model, we can go from a very simple one just to test out some concepts to more complex ones to see how it would really work in the supply chain. From the services layer, we're looking at some of the services that could be brought to bear to either acquire information from the supply chain and provide it to the blockchain, or acquire from the blockchain and provide to the supply chain. We also look at, and I talked before about establishing trust between trading partners. One of those aspects of trust may be, is your license up to date and valid? And so we looked at what would take place if licensing authorities were able to make that information available within as a service. So that's an overview of how we started to define reference models. We also started to talk about the data, where it would exist in each one of our models. So you see here the events, the commissioning, shipping, aggregation, and the kind of data that would be up in the blockchain. And this follows, being as this is based on GS1 identifiers and GS1 EPCIS or track and traceability standards, this follows along with the data model that exists in those standards. We also look at processes that would need to take place in order for these events that occur within the supply chain, for the data around those to be pushed into the service area and then up into the blockchain, and the steps that would take place. And again, we're looking at the steps in order to make them as few as possible and as simple as possible. Likewise, we looked at how to retrieve data from the blockchain. So if I'm a dispenser and the FDA or a board of pharmacy audits me and I need to retrieve information about that item that's on my shelf, how do I go about doing that, and what takes place in the services area and what takes place up in the blockchain area? So as I said before, I've been talking about kind of frameworks from so far, but as we started to look at, and the team started to discuss different models and just wanting to explore certain things, we actually created 9 different models. Now, you'll notice that number 5 isn't there anymore. It turns out that was duplicate of something else. But we've got a number of different kinds of models, and I'll point out 2 of them in a moment. But number 1 is just the minimal data in the blockchain, and other data, master data about products, would be accessible somewhere else. And then you see flat models, you see models where everybody gets to see everything, and then you see models where just the pointers to data is put up in the blockchain, and so on. So different ways that we explored sharing information using this technology and how it impacted the supply chain and how information flowed and how much information flowed. So let me just point out 2 of these models. We're going to look at now reference model number 1 and reference model number 6. So number 1 is a minimum amount of data up in the blockchain. And what do I mean by that? So just the transactional data up in the blockchain. Master data about products, can be acquired through services such as the Global Data Synchronization Network, GDSN from GS1, or it could be captured through catalogs and a number of different ways that data about products is retrieved and captured by the trading partners. Also, trading partner data such as supplier data, location data, and customer data. So if we look on reference model number 1, a minimal set, so essentially creating an EPCIS event, commissioning, shipping, receiving, unpacking, packing, that type of thing, moves from the supply chain up into the service level where it's QC'd or quality controlled, make sure the data is straight before it goes into the blockchain. Then it's just tested again and it's provided into the blockchain and shared within the blockchain nodes. Likewise, when there's a query for information about the transaction information for previous transaction, that information is retrieved from the blockchain. It's provided to a service area in this model, and that service area formats it properly for consumption by the blockchain participant. So that's a model where actual DSCSA data is being put into the blockchain. Now contrast that with another way of doing it, which would be that I provide information, DSCSA data. It's then stored for me in either a database or maybe a different blockchain application, but it's off the main data persistence area. Instead of data going up to the blockchain, the identifier or the address of where that data exists goes into the blockchain. So now when I'm asking questions of the blockchain about a particular item, the address of that item comes down, and my service provider then can go and retrieve that data and provide it to me. So you see two different contrasts here. One of providing actual DSCSA data up into the blockchain that's shared by everyone, and the other one being I'm putting up pointers to data that exists elsewhere. And indeed, as we start to talk through this, it may be that we're looking at a hybrid model of a little bit of both of these things. So maybe we want to put DSCSA data up there, but some of the supporting data, such as invoices or shipping documents, we may hold elsewhere. So those are the kind of learnings and experimentation that we did as we moved through this study. So now, just to sort of wrap up a bit, we are going to take the work of the phase 2, which was in a simulated environment, and now start to take that outside and start to build examples of those reference models that you saw. And so the concept here is that solution providers will well, first the industry itself would come together to determine the set of features that are most desirable. We went through a lot of work in the past, in this current study, discovered a lot of things. We've got a tremendous amount of documentation. Not all of that needs to be part of proof of concept pilots. So we'll determine what needs to be put into a pilot. Certainly things like performance measures, how fast can transactions go up into the blockchain and be available? What about volume? Can it handle 6 million transactions in a few hours? Those type of things. Certainly we'll be able to, we really can't test those in earnest in a simulated environment, but those are more for proof of concept kind of pilots. We'll then match the technology and industry companies that want to do pilots. So this may not be one big giant pilot. This may be a series of pilots that test out various aspects that we've discussed in our phase 1 pilot. And then we'll actually have those scenarios built out, and we're looking to have a session in the spring where we actually are able to do structured walkthroughs of each of those pilots or partial pilots to understand what the goals were, what took place, and what was learned from actually providing and building out a pilot. So this fall we'll continue with the organizing that pilot or study. We'll do feature set selection, and then we'll start pairing and working on the pilots themselves, and then in the spring demonstrating to the community what we've learned and what's been built. So there's a lot of material from the phase 1 study that will be available to the phase 2 teams. Obviously the overall structure, data governance rules that we've developed, we can test out in the proof of concept pilots. Some of the ways that technology can be brought to bear, such as single blockchains, multiple blockchains, and so on, can be leveraged by the phase 2 team. The supply chain itself, the processes that we've gone through, the scenarios that we've documented and worked through, forward and reverse logistics, suspect, illegitimate, and clear drugs, and then some nefarious behavior we've added into our models, such as counterfeit, diversion, or theft. Different policies that we've tested out through the phase 1 is available to phase 2 participants, and also how the behavior of the different supply chain partners, manufacturers, contract manufacturers, 3PLs, and so on, that we've identified is available to phase 2 participants. And also the kinds of services that we've identified will also be available. So we may have proof of concept pilots that talk about how do I pull information from the blockchain and marry that with master data. And so that might be an interesting interaction and pairing up of maybe a company that provides master data management and also a company that's well into blockchain and interact and marry that data back together. All of the performance measures that we've identified in phase 1 will be available in phase 2, and in fact, a lot of those will be looking to test in some of those pilots: scalability, timing of providing data to a blockchain, and also querying information. The actual simulations will be available to phase 2 participants along with the data. So we may be able to generate a tremendous amount of data from our simulation to be able to test in the proof of concept. Again, as I mentioned, if we're looking at millions of transactions, we can create that within the simulated environment and provide that to the proof of concept pilots. And all of the flows so that we understand what we're actually going to test in the proof of concepts. Lastly, another study that we'll be kicking off shortly is Blockchain for Cold Chain study. Again, we'll be leveraging the work of our current study. And really in this one is we're looking at how do we manage a set of cold chain temperature sensor, and we may go beyond just temperature. We may be looking at humidity and pressure and vibration and what have you, light, any kind of sensor data, and how do we marry that and move that through the same process? So how do we take advantage of the fact that we've already defined a way for trading partners to share information even if they're not adjacent trading partners? That may be helpful in cold chain kind of study. So just to wrap up, we are just about to release the drafts on the prospectuses for phase 2 and the cold chain studies. So we'll continue some of these conversations that we're having now. Next week, we'll be starting pre-launch calls, and you all will get an invitation to those calls. And those calls they serve two purposes. One is to start to gather the team and have the appropriate discussions for moving into the study. And it also gives times for companies to work through the paperwork of the agreement that has to be signed in order to be part of a study, and work through that paperwork without providing too much of a gap in process. And then we'll move in earnest into the study itself, and then later publication. So we'll go through that process in a short period of time. So with that, I'm going to try to open up the phones and see if there's any questions. I've had difficulty in this in the past in that we have had some conversations that have been going on and are hard to unmute people. So let me just see if I can do this. If I can't, then we'll have to go to all right, so if you're having a conversation, be careful because everybody's going to hear you now. Okay, I've opened up almost all of the lines that I can open. There's some I can't for whatever reason. But if you do have any questions about what I presented or the studies themselves, I'd be glad to entertain those now. Okay, if not, I don't expect that everybody should have questions. I just put everybody on mute because I heard some feedback loop going on there. I just want to thank you for being on the call today. I hope this was informative. We will provide this information on our website, both the recording that we just went through and the slides themselves for you to download. If you'd like to discuss the upcoming studies or the current study, please feel free to reach out to me either by phone or email, and I can set up a separate time for us to talk and go through what your questions are, and hopefully you'll join the upcoming studies. I think they're going to be very interesting in applying the work that we've done this past year in exploring both blockchain and exploring certainly the nuances of how the supply chain works within pharmaceuticals. So thank you everyone for being on the call, taking the time today. Again, feel free to contact me. I'd be glad to talk to you about what we're doing and how you can become involved. And I hope you do become involved, because I think this is important and interesting work. Everybody have a great weekend, and hopefully we'll talk to you soon.